Welcome to the today's tutorial. Today we are going to discuss about the critical points and we will solve examples to find the critical points of many functions. So first thing, that what is critical point of a function? A point C in a domain of a function fx is a critical point if f dash c is equal 0 or f dash c is not defined. So what are the steps we need to follow to find the critical points? So step 1, find f dash x. Step 2, determine all points so that f dash x is equal or f dash x is not defined. Step 3, identify those points obtained in step 2 are in the domain of fx. So we need to follow these 3 simple steps to find the critical point. Let's discuss the remaining with the example. So our first question is, find all critical points for fx equal x to the power 3 plus 6x square plus 9x minus 8. So we'll solve it by step solution. So step 1, find f dash x is equal 3x square plus 12x plus 9. Step 2, f dash x is equal 0. This means 3x square plus 12x plus 9 is equal 0. So this implies 3x square plus 4x plus 3 is equal 0. 3, this is x plus 3 and x plus 1 is equal 0. So this implies x plus 3 is equal 0 or x plus 1 is equal 0. So this implies x is equal minus 3 minus 1. And both the points are in the domain of the function fx. So step 3, the critical point sometimes we just short it as CP are minus 3 and minus 1. Step 1, f dash x is equal 15 x to the power 4 minus 30 x square plus 15. Second is f dash x is equal 0 implies 15 x to the power 4 minus 2x square plus 1 is equal 0. So this implies x to the power 4 minus 2x square plus 1, which is equal x square minus 1 whole square, which is equal 0. This implies x square minus 1 is equal 0, which is further x minus 1, x plus 1 is equal 0. So this implies x is equal plus minus 1. Step 3, critical points are plus minus 1. So here we have to find the derivative f dash t, which is equal, we have to apply the quotient rule, t square plus 60 plus 7 whole square. Then you have here t square plus 60 plus 7. Derivative of t plus 5 is 1 minus t plus 5, and derivative of t square plus 60 is 2t plus 6. So we'll try to simplify it. T square plus 60 plus 7 whole square. Now simplify this. So you will have t square plus 60 plus 7 minus 2t square minus 10t minus 60 minus 30. So this is equal t square plus 60 plus 7 whole square, and this is minus t square minus 10t and minus 21. So now the question is that where the function is derivative is 0 and where it is not defined. So f dash t is not defined if t square plus 60 plus 7 is equal 0. But from ft it is clear that t square plus 60 plus 7 is not equal 0 for all t. So now we need to check where f dash t is equal 0. F dash t is equal 0 if the numerator, that means t square plus 10t plus 21 is equal 0. So this implies t is equal minus b plus minus p square minus 4ac over 2a. So this will gives you minus 10 plus minus 4 over 2. So critical points are t is equal -7 and minus. Next question is find all critical point for y equal minus ln cosine x. So we have to be clear that when the ln cosine x is defined, solution y dash is equal minus 1 over cosine x derivative of cosine x, which is equal sin x over cosine x is equal tan x. Second, y dash is equal 0. This implies tan x is equal 0, which is implies x is equal 0. Here we will take only the domain from minus pi over 2 to pi over 2. So x is equal 0, and we can clearly see that at x equals 0, cosine 0 is 1. So therefore ln 1, which is defined. So x equals 0 is in the domain of the function. So the critical point x is equal 0. For this problem, we will apply the chain rule. So step 1, f dash t is equal 3 minus 2t, and derivative of e to the power 2 square will be 2t e to the power t square, and then the derivative of 3 minus 2t will be minus 2 e to the power t square. So this is equal e to the power t square 60 minus 4t square minus. Second step, f dash t is equal 0 implies e to the power t square 60 minus 4t square minus 2 is equal 0. Now e to the power t is never 0 for any t. So this implies minus 4t square plus 60 minus 2 is equal 0. So this will gives you t square minus 60, 4t square minus 60 plus 2 is equal 0. For the simplification, 2t square minus 3t plus 1 is equal 0. So if you can do the factor, 2t minus 1, t minus 1 is equal 0. So which is implies t is equal half and 1. So step 3, critical point are half and 1. Okay, find all critical points for f x equal ln 4x square minus 3 ln x plus 3. Solution. First step, f dash x is equal, so we'll take the derivative 1 over 4x square minus 3 8x minus 1 over x plus 3. So this is equal 4x square minus 3 x plus 3 8x square plus 24x minus 4x square plus 3. So this is equal 4x square plus 24x plus 3 over 4x square minus 3 and x plus this a. F dash x is not defined if 4x square minus 3 is equal to 0 and x plus 3 is equal to 0. But in both cases, f is also not defined. Part B, f dash x is equal to 0 if 4x square plus 24x plus 3 is equal 0. If you can solve it by factorization, that's okay. If you cannot, then solve it by the quadratic rule. That means x is equal minus b plus minus b square 24 square. 24 square, which is 576 minus 4ac, so 48 over 2a 8. So this is equal minus 24 plus minus 538 over 8 equal minus 3 plus minus square root 538 over 8. That's the critical point. So find all critical point for gy is equal e to the power 3y to the power 4 plus 12y. So we need to apply the critical. So we need to apply the chain rule here. So step 1, g dash y is equal e to the power 3y to the power 4 minus 12y, then derivative of d dy 3y to the power 4 minus 12y, which is equal to the power 3y to the power 4 minus 12y. This is 12y to the power 3 minus 12. Second is g dash y is equal 0. This implies e to the power 3y to the power 4 minus 12y. 12y to the power 3 minus 12 is equal 0, which is equal y to the power 3 minus 1 is equal 0. So if you factor it here, y minus 1, y square plus y plus 1 is equal 0, which implies y minus 1 is equal 0, y is equal 1. And another is y square plus y plus 1 is equal 0, which is gives you y is equal minus b 1 plus minus b square, so 1 minus 4ac over 2, so which is minus 1 plus minus square root 3 iota over 2. Since we are dealing with the real number only, so critical point, so y is equal 1. So we ignore the complex roots, this one, for the this type of the problems.